we have signs of very great changes occurring on the planet.
Everything happens so fast.
There's creeks dried up that have never dried up in my lifetime.
We've got a forest here that's already at the edge.
We're going into uncharted territory.
Our planet is at a crossroads. Global warming isn't out of control, but it soon could be. The warning signs are all around us. This is the challenge of climate change. What can we do about global warming? What will happen to the Earth if we don't? The temperature is rising. Each degree is critical.
Just 1 degree or so of
1 degree warmer than they should. Bump it up 2 degrees.
3 degrees.
Threshold is about 3 degrees of global warming.
3 to 4 degrees of warming.
You're starting to look at 4 degrees.
3 degrees, 4 degrees, 5 degrees.
6 degrees is almost unimaginable.
Imagine the 21st century if global warming accelerates. Where does the next superstorm hit? The next scorching heat wave? The next catastrophe? As the world warms degree by degree, the debate has ended. Scientists around the globe agree we now live in a world warmer by almost 1 full degree Celsius. Tracking the Earth's vital signs is an armada. Thousands of ships at sea, tens of thousands of stations on land, satellites monitoring from space. Scientists feed the data into the most advanced computer models. The predictions are alarming. In 4 decades, glaciers in the Himalayas, the source of water for millions, could be gone. Within 50 years, Greenland's melting ice sheet could be unstoppable. By the end of this century, the Amazon rainforest, home to half the world's biodiversity, could wither to an arid savanna. A temperature rise between 1 and 6 degrees Celsius is possible over the next century. Each degree means a radically different future.
Global warming doesn't just mean the slow increase in average temperatures. It completely changes the way the Earth system operates, which is why we can see droughts in one place, floods in another, or even a succession of drought and flood in the same exact location.
National Geographic author Mark Linus spent years compiling data from climate models to understand how each degree of warming could threaten the planet.
It's very difficult for people to visualize the future impacts of global warming, and it's something that I really wanted to try and do to help people visualize the reality, because it isn't actually intuitive that the emissions from your car exhaust are going to be melting a glacier in the Himalayas in 50 years' time.
While experts estimate the average temperature could rise up to 6 degrees Celsius, or nearly 11 degrees Fahrenheit over the next 100 years, the future isn't set in stone. Even a small shift in the Earth's temperature, just 6 degrees, can have extreme consequences.
Well, 6 degrees shift from one day to the next is the sort of thing that we expect with normal weather fluctuations. If it's 6 degrees hotter tomorrow, I might just be wearing some shorts. 6 degrees in terms of a global average change, 6 degrees colder is the difference between now and the last ice age, 18,000 years ago, when the ice sheets themselves advanced to just the edge of Oxford, and in places the ice cap was more than a mile thick.
just 6 degrees of cooling transformed the Earth into an ice age. Imagine it 6 degrees hotter. The very earliest changes would start high above the Earth. The atmosphere is our buffer zone between the planet's surface and outer space. A small percentage are the greenhouse gases, a cocktail of water vapor, carbon dioxide, methane, nitrous oxide, and ozone. They are like a dome over the planet, retaining just enough of the sun's reflected energy to maintain temperatures that support life. As the amounts of those gases increase, they trap more heat and can radically affect the climate all over the planet. For the last 250 years, greenhouse emissions have soared as we find more and more ways to use more and more energy. CO2 is the hidden price we pay. Carbon dioxide rises into the atmosphere from the energy that powers all our modern conveniences. It's literally in the air we breathe. There are now 383 carbon dioxide molecules out of every million. It seems minuscule, but as the amount of CO2 rises, so does the average temperature all over the planet.
Doubling of CO2 is a guarantee for a global disaster. The dangerous level is about 450 parts per million, and we're already up to 383. Additional global warming of 1 or 2 degrees Celsius is a very big deal.
All we're doing is saying what we think our best estimate is what will happen if we carry on the route we're going. So all you can do is to lay out a number of possible pictures of the future and hope people will select the right one.
If the world warms by 1 degree, the Arctic is ice-free for half the year, opening the legendary Northwest Passage for ships. Tens of thousands of homes around the Bay of Bengal are flooding. Hurricanes begin hitting the South Atlantic. Severe droughts in the western U.S. cause shortages in global grain and meat markets. This could be our world plus 1 degree. Warming of just 1 degree could turn some of America's most fertile ranchland into desert again. 6,000 years ago, much of the American West was part of a vast desert dominating the continent. A minor shift in the Earth's orbit caused the summer sun to warm slightly, just enough to radically transform this entire region. Only a very thin layer of topsoil covers the desert sand that still lurks just centimeters below the surface. As we race toward a planet warmer by 1 degree, the global warming scorecard lists both losers and winners. While the western U.S. is dry and thirsty, England is enjoying an agricultural makeover. Fortunes will be made and lost if global weather patterns rearrange where different crops can be grown.
The winters, which used to be very hard in this country, are getting much, much milder, and so in some senses that's a good thing. That's of course not counterbalanced by the devastation which is affecting other parts of the world.
Right now, England is in the right place at the right time for one of the world's most fragile and most valuable crops.
You can't have it too hot for grapes. Of course, you realize in the Champagne region now it's becoming too hot.
When David Middleton first planted Champagne-style grapes, neighbors thought he'd gone mad. But as wine-producing regions in France are getting hotter, the climate for growing grapes is migrating across the English Channel. The idea of a fine English wine is no longer a joke. Now there are more than 400 vineyards in Britain. The Earth's average temperature has always fluctuated, and a variable climate isn't unusual. It's the pace of climate change today that's unprecedented. The planet has experienced climate change before, but it usually plays out over thousands or millions of years. Now global warming is measured in decades, even years. It means scores of species won't be able to keep up. Warming at this speed could send us into uncharted territory, like nothing we've experienced in the history of life on Earth. Global warming started with our insatiable appetite for energy. Every switch we flip, every plug, every button we push to turn something on inevitably leads back to a place like this. Nearly 90% of the world's energy starts as a fossil fuel. Coal, oil, natural gas. These three fuels combined are the single largest source of CO2 emissions pouring into the atmosphere. If the world warms by 2 degrees, some changes to the biosphere are no longer gradual. Greenland's glaciers are disappearing. So much ice has melted, polar bears struggle to survive. Insects migrate in strange new directions. As a temperate climate moves north in the US, pine beetles kill off the white bark forests, a grizzly bear's key source of food in the fall. New forests take root in Canada's melting tundra. The Pacific islands of Tuvalu are lost beneath the rising tides of global warming. This could be our world plus 2 degrees.
At 2 degrees of warming, the impacts in the marine ecosystem are going to be much more severe.
The oceans are the planet's largest carbon sink, nature's primary mechanism for absorbing CO2 out of the atmosphere. But lately, there are indications these systems are breaking down. Under normal conditions, tiny sea creatures like forams and coccolithophores absorb carbon out of the water and use it to build their shells and skeletons. But there is a tipping point when too much CO2 in the oceans turns the water increasingly acidic. Acidification dissolves the creature's shells and skeletons and prevents them from absorbing more CO2 out of the water to build new ones. Some of these tiny animals at the bottom of the food chain measure only 1 millimeter. But the fate of all sea creatures, of all shapes and sizes, larger and larger, hangs in the balance. Alter the ocean's chemistry, and nature's primary mechanism for controlling the climate begins to break down.
You lose a coral reef, you lose perhaps 500,000 species. You lose those little coccolithophores, these little algae, and you start to lose things that are very important to life on this planet. We're losing some of the most vital elements of the way the world works, and that's got us all concerned.
Scientists half a world away share those concerns. They're investigating global warming at the climate's opposite extreme. It took nature 150,000 years to make the Great Greenland ice sheet that's now melting into the sea faster than at any time in history. As it disappears, rising oceans will flood coastal cities around the world. Greenland's Jakobshavn Glacier is the fastest moving ice field on the planet, more than 40 meters per day, melting into the sea twice as fast as a decade ago. Rising temperatures are transforming one of the Earth's harshest climates, disrupting the way people have lived in Greenland for hundreds of years. For as long as anyone can remember, sled dogs have been a symbol of wealth here and a necessity for survival, especially for hunting across the winter sea ice. When the winter ice started thinning, dogs became an expense most islanders couldn't afford. In this town of 4,500 people, there are 4,000 dogs, with very little to do these days. Many are starving. Some are being put down. Marit Holm is one of Greenland's 5 veterinarians. As she patrols the town of Ilulissat, she sees the impact of climate change in every sled dog without a sled to pull.
So that's what I do. I drive around and look after the dogs. The dogs are hungry, so I have to be a little bit careful not to get bitten. And when the dogs are hungry, they are a little bit more dangerous to people and kids walking around. It doesn't seem to be sick. He's very skinny. So I have to try to find out who's the owner and talk to him.
These animals were once in peak physical condition. They served a vital purpose in their owners' lives.
That's a thing of the past, and we don't see any young people who takes some dogs and live as a fisherman and a hunter.
Dogs have been in Finn Sistel's family as long as he can remember. He finally gave up his team of 19 just in the last few years.
In the winter, even though it was an impossible thing to do about 20 years ago, most of the fishermen go out with a boat today instead of dog sleds.
When Finn was growing up, this was their winter hunting ground. Solid ice for more than half the year.
Everything happens so fast. It's so visible, you don't have to be a scientist to determine what's happening.
With each passing season, Finn watches as traditions locked in the ice melt away.
There's something interesting in the side because you can see small bubbles. And these bubbles are older than all living creatures in the world. And you can listen to it. Because the bubbles are so compressed. And when they get out, it's like popping. You can talk to the ice.
That's what an intrepid team of scientists does once a year. Fly into Greenland's interior to listen to the ice. Swiss Camp is a scientific research installation built directly into the glacier to track climate change. Dr. Conrad Steffens has erected 23 full-service weather stations that take a complete range of climate measurements every 15 seconds, updating global warming computer models all over the world.
The ice sheet is very old. It's over 150,000 years old. If we start to remove it, then we actually start a process that is unknown to civilization. We have never seen Greenland disappearing. Watch it, watch it, watch it.
In 1992, 5.6 kilometers of glacier was slipping into the sea and disappearing. 10 years later, that number more than doubled to 15.5 kilometers annually. Steffens wouldn't understand how warmer weather affects the speed of glaciers until he came upon one of the strangest and most dangerous features of this forbidding landscape. Rivers of melted ice are cascading straight down into the glacier, creating huge tunnels called moulins. The team lowers a fiber optic camera. Their hypothesis? That meltwater has cut all the way through to the bedrock a quarter of a mile below and is lubricating the underside of the glacier, propelling it faster and faster into the sea.
50 meters! My God! 60 meters!
For Steffens and his team, it is a chilling moment. This shaft, and many like it, go all the way through the glacier, revealing a whole new mechanism for speeding the ice sheet's disappearance. It's melting so rapidly now, oceans could rise as much as a meter over the next century. The consequences could be catastrophic.
The Greenland ice sheet actually contains enough frozen water to raise global sea levels by about 7 meters, which is enough to flood most of London, Bangkok, New York, Shanghai, you name it.
Many scientists focus on 2 degrees of warming as the tipping point that will fundamentally change how we live on this planet. This could be where global warming becomes a runaway train. Warming accelerates the loss of polar ice. The loss of ice accelerates warming. More water from melting ice absorbs more of the sun's heat, melting the ice sheet and heating the planet even faster. The warmer it gets, the faster it gets warmer. That's when global warming becomes a chain reaction we can't easily predict. If a rise of 2 degrees doesn't push the planet to the tipping point, many scientists predict 3 degrees will. If the world warms by 3 degrees, the Arctic is ice-free all summer. The Amazon rainforest is drying out. Snow caps on the Alps all but disappear. El Niño's extreme weather patterns become the status quo. The Mediterranean and parts of Europe wither in searing summer heat. This could be our world plus 3 degrees. The summer of 2003 may have opened a window onto life in a world that's 3 degrees warmer. All across Europe, an unrelenting heat wave developed into a natural disaster. Paris tends to empty in the summer. Many elderly stay behind. Nobody could have anticipated the danger they'd be in. Emergency room doctors were the first to realize something was terribly wrong. Dr. Patrick Pellew quickly realizes the heat wave is turning into a catastrophe.
You had such a heat wave, comparable to a flamethrower, igniting an entire area.
Le nombre de personnes qui sont mortes dans la nuit du 10...
The number of people who died on the night of August 10 is between 2,500 and 3,000.
The city's distinctive metal roofs were designed for an earlier era to protect against winter chill. Now rising temperatures have turned them against the Parisians. The death toll would top 30,000 across Europe. In France alone, over 14,000 died in just a few weeks. During the heat wave of 2003, another little-noticed phenomenon among Europe's trees and plants was unfolding, a kind of vegetation backlash. Photosynthesis was breaking down. Under normal conditions, plants and trees are a first line of defense against greenhouse gases, absorbing CO2, then converting it into oxygen and releasing it back into the atmosphere. But in the extreme heat that summer, some plants retained oxygen, releasing CO2 into the atmosphere instead. What happens to the biosphere if one of the planet's most important mechanisms for converting CO2 into oxygen stops working on a regular basis? Possible answers are emerging here at England's Hadley Centre, one of the world's foremost facilities for forecasting where our climate could be headed. Trying to peer decades into the future keeps climate modelers at their desks over time.
Tea and coffee?
One of their toughest challenges is calculating the effect of +3-degree warming on the Amazon rainforest, where 20% of the world's oxygen is produced.
We wanted to know how climate change in the future would affect tropical rainforests, and in particular the Amazon, because it is such an iconic region, important both environmentally, ecologically and economically.
The climate model produces an ominous prediction. 3 degrees of warming could trigger a catastrophic feedback loop, accelerating global warming even more, possibly reducing one of the wettest places on Earth into a patchwork of arid savanna.
Occasionally it takes someone to come from outside and say, well, do you know what that means, don't you? You're talking about the death of the Amazon.
Summer 2005, the Amazon River. Extreme heat teems with the driest conditions anyone can remember. Few can recall a time on the mightiest river in the world when its tributaries ran dry, not low, dirt dry.
In 2005, we saw a situation in the Amazon which was just incredible. It was completely off the scale. The Brazilian army actually had to fly by helicopter huge quantities of water up the dried up Amazon tributaries in order to stop people dying of thirst in villages which are normally on the edge of this enormous river.
First drought, then fire. In the aftermath of summer 2005, over 2,500 square kilometers of the rainforest burn. Trees help generate 50% of the water for rainfall in the Amazon. As more forest is lost, the very source of the Amazon's rainfall diminishes.
For every tree that we lose, we're making one more incremental step towards a scenario of drought and fire in the region.
Ecologist Daniel Nepstad has been studying the Amazon for over 25 years and sees global warming and deforestation pushing the region toward a tipping point.
We think that maybe as early as 20 years from now, we're going to see what we call positive feedbacks kick in, these vicious cycles of drought leading to fire, leading to more drought. And that's much sooner, of course, than the climate models are giving us.
In the the extreme conditions of a world warmer by 3 degrees, losing much of the Amazon could cause the re-release of hundreds of millions of tons of stored carbon, perhaps intensifying global warming another degree.
If we get to 30 years from now and the Amazon is brushland, I think I would look back and say we had a chance to save one of the world's great treasures. A place that's intimidating in its vastness and its complexity. And it's so grand in scale that it really is reaching its influence around the entire planet. Everyone in the world in some way is tied to this ecosystem, and I think in looking back I'd say we had a chance and we blew it. Humanity had a chance.
In a world warmer by 3 degrees, climate change could be manifest in the most violent weather humans have ever experienced. As the oceans get hotter and hotter, a new global climate pattern emerges, mirroring the violent weather anomaly we call El Niño. But in a 3-degree world, those extreme conditions could become the status quo. Normally, the trade winds drive warm ocean currents toward the western Pacific, leaving cold, nutrient-rich waters along the coast of South America. El Niño turns that system upside down. The first signs are wild fluctuations in air pressure. The trade winds weaken and completely change direction. Warm water spreads east across the Pacific. Torrential rains and flooding strike coastal South America. Indonesian rainforests and Australian farmland experience extreme drought conditions. And many climate models include another troubling forecast. Continued warming could turbocharge a new generation of superstorms.
In a world which is 3 degrees warmer, there's going to be a lot more energy in the world's oceans to drive hurricanes. And hurricanes derive their rocket fuel from the warming of the ocean.
Scientists are still investigating a connection between global warming and hurricane strength. The summer of 2005 would bring dramatic new evidence. In late August, a Hurricane Hunter aircraft is dispatched over the Gulf of Mexico. A colossal storm is building and tracking straight for the city of New Orleans. Anyone left there has only one word in mind: Katrina. By Sunday, August 28th, Katrina's winds reached 280 kilometers per hour. Thermal imagery along the storm track reveals Katrina's clout. Orange and red indicate the sea temperature has risen to 82 degrees Fahrenheit, a full degree higher than normal. Dropping pressure within the eye wall is the 4th lowest ever recorded for an Atlantic storm. It revs Katrina even more. When Hurricane Katrina makes landfall in New Orleans, it unleashes a terrible fury. Within 6 hours, the storm is on its way out of the city. But the destruction of New Orleans only gets worse, transforming the natural disaster into a national tragedy. jazz trumpeter Irvin Mayfield grew up in New Orleans. The storm surge and a breach of the London Avenue Canal sent 2.5 meters of water into Mayfield's neighborhood. His father stays to protect the family home. His body won't be found for weeks.
When someone has lost their high school, their junior high school, their elementary school, their pictures, their videotapes, their clothes, their friend's house, their friend's mother's house, their barber shop, the place they had their first kiss, you know, when you lose all that, and some people lost loved ones, when you have all of that come together, it's you can't imagine a type of tragedy, a citywide catastrophe, not even rivaled by September 11th.
It's impossible to directly link Katrina to global warming. The process that forms hurricanes is too complex. But if the planet warms by 3 degrees, we could be in for a new generation of superstorm. If the Earth reaches plus 3 degrees, over the next 40 or 50 years, the planet's basic life support systems could begin to break down. But beyond 3 degrees, the science of global warming becomes more and more speculative and more frightening. If the world warms by 4 degrees, oceans rise, overtaking heavily populated deltas, home to 1 billion people. Bangladesh washed away. Egypt inundated. Venice submerged. Glaciers disappear, shutting off the flow of fresh water to billions more. Northern Canada becomes one of the planet's most bountiful agricultural zones, while a beach in Scandinavia could be the next Saint-Tropez. The entire West Antarctic ice sheet could collapse, sending sea levels rising even further. This could be our world plus 4 degrees.
At 4 degrees, we really do begin to see a planet which is completely unrecognizable from the one we know today. We will see the possible drying up of some of the most important rivers in the world, and this will endanger the survival of tens and even hundreds of millions of people.
If the planet is ever 4 degrees warmer, one of its great rivers will be self-destructing at both ends, from a high mountain glacier to the Indian Ocean. Locals call it Mother Ganges, the holiest river in India, perhaps in all the world. Millions of devout pilgrims gather each year in a mass ritual to celebrate the river's birthday. When it is said the goddess Ganga came to earth to save her people from drought. Himalayan rivers are the wellspring of life for over 1 billion people in China, Nepal, and India. Unless we begin to slow global warming, in fewer than 4 decades, the Ganges could be a river fighting for its very life. The battle will be fought here, in the vast crystalline ice fields of the Himalayan glaciers, the planet's largest store of fresh water outside of the polar ice caps. Himalayan glaciers are receding, the fastest of any in the world. Few have ventured here to the headwaters of the Ganges as often as one man. Swami Sundaranand, an 80-year-old holy man known as the Swami who clicks, has been photographing the glaciers above the Ganges for 50 years.
1956 में सर्वप्रथम
The first photo I took of the glacier was in 1956.
ये मैंने गंगोत्री की
After 1962, I started to worry about the changes I was seeing in the glacier.
1965 में
I went to this glacier on foot in 1965 to the base of Meru Peak.
अब उसके बाद 15 वर्ष के बाद जब गया
When I went back after 15 years, the glacier had vanished.
क्योंकि मैं पर्यटक बना
When I saw the glacier receding, I became very worried and started crying.
1000 मील लंबा हिमालय
If the holy Ganges is not in existence in the future, the entire world will seem like it has become an orphan.
The Swami's trove of icescapes documents 50 years of change to this magnificent glacier. Now, NASA satellite imagery confirms the rate of loss. Side by side, the high and low-tech images tell a similar story, one that spells danger for the future. This was all glacier once, before it started shrinking 30 meters a year. Just a century ago, this stone marked the edge of the ice field that has retreated high up the mountain. If the world warms 5 degrees, 2 massive uninhabitable zones spread into once temperate regions of the northern and southern hemispheres. Snowpack and aquifers that feed the world's great cities, Los Angeles, Cairo, Lima, Bombay, are drying out. Climate refugees number in the hundreds of millions. This could be our world plus 5 degrees.
If we allow global warming to take off that far, I really do see a situation where we have conflict across vast areas of the globe as the people who remain and the people who survive fight it out with each other for what remains of the world's resources.
And it can get even worse. If the world warms by 6 degrees, from a distance, the oceans may appear bright blue, but they are marine wastelands. Deserts march across continents like conquering armies. Natural disasters become common events. Some of the world's great cities are flooded and abandoned. This could be our world plus 6 degrees.
Warmings of 6 degrees over longer time periods have been associated with some of the most devastating mass extinctions which have ever taken place. So it's certainly fair to assume that if temperatures soar by 6 degrees within less than a century, that we're going to face nothing less than a global wipeout.
6 degrees of warming has been called the doomsday scenario. Our lives would never be the same again. But it's not all doom and gloom yet. Most experts believe we can awaken from the nightmare. Right now, the average temperature has only risen 0.8 degrees Celsius. But we don't have much time.
We're talking about turning around the energy supply for most of humanity within the space of a decade.
For anyone looking for solutions, there's no place like home. This is the Cohen residence, a pleasant 3-bedroom in Snowmass, Colorado. But lurking beneath the surface, an energy-eating monster. Many homes waste more energy than they use. a team of eco-detectives is investigating the Cohen house for crimes against the climate.
This innocent-looking thing here, when it is on, eats a whole lot of money. When I feel this much cold on the outside of the freezer, I know that the insulation is really not as thick as we would like. Oh, what have we here? Climate change is a problem we don't need to have, and it's cheaper not to.
For Amory Lovins, solutions start with efficiency,
It's going to bounce up on the ceiling.
reducing the use of energy that produces CO2 emissions.
Do you see that little red light down in the corner?
Yes.
And this whole entertainment center goes through one plug, so I'm going to plug it in through the meter now.
If you have all kinds of appliances, you know, your TV, your VCR, your DVD, etc., that have that little light on,
Yes.
they're using electricity. It's called vampire loads.
109 watts, almost 60 bucks a year just sitting there turned off.
Lovins doesn't just talk the talk. He lives in a house he designed without a furnace in Aspen, Colorado, where temperatures in winter routinely drop below -17 Celsius.
We're at 7,100 feet here. It can go to -47 F, get frost any day of the year, and we can get 39 days of continuous midwinter cloud.
Lovin's house is a mix of high technology and homespun common sense. Solar units on the roof produce more electricity than the house uses. The entire house runs on just 120 watts, slightly more than a single light bulb.
Energy efficiency is the biggest, fastest, cheapest way to solve the climate problem, to save money, and to make a safer, richer, fairer, cooler world.
Next to our homes, the second largest source of emissions we're responsible for is parked right outside. Cars produce nearly 20% of global greenhouse gases. To keep warming below the critical 2-degree threshold, we need to cut 7 billion tons of greenhouse gas emissions every year. Doubling the average fuel efficiency of all cars from 25 kilometers per gallon to 50 would save 1 billion tons. But we would still need to cut billions more from our carbon footprint to stay on the safe side of +2 degrees.
We have an arsenal of solutions already. It's going to be solar, and it's going to be wind, and it's going to be tidal power, and it's going to be thermal power. All of these different things working together actually give us a pretty good ability to get away from the fossil fuel economy.
The ultimate answer may be just over the horizon. But the problem continues to grow. With each passing year, we consume more energy. The future will test the best minds in science. An international team of physicists in England has already started attempting the mother of all technological solutions: nuclear fusion. They're building a fusion reactor modeled on the single best power plant in the solar system, the sun. Harnessing that same power could mean a virtually limitless and self-sustaining source of energy without producing any greenhouse gases.
This energy lights up the universe, powers most of the stars in the universe. So what we're trying to do here is to replicate the same process on Earth and use this amount of energy to produce electricity.
It won't be easy. The core of the reactor will be nearly 10 times hotter than the sun. A powerful magnetic field contains the superhot plasma and prevents it from melting through the reactor's walls. Even if it works, and there's no guarantee, the reactor won't produce commercial electricity for at least another 30 years. As ambitious as it may be, fusion may appear relatively down to earth. Imagine outer space filled with a cosmic fleet of mirrors. One current research project estimates that 1 million mirrors, each about 3 feet across, could block out enough of the sun's heat to lower the Earth's temperature.
It's no good sitting around hoping that someone's going to invent some fantastical new source of free energy. The reality is we have to deal with what we've got, and we have to do it within 10 years.
The world's appetite for energy remains voracious. Our carbon footprint is staggering. As global warming escalates, it also accelerates. At some point, climate change could take on a life of its own, and global warming would become a runaway train. The only question is, now that we know about it, what are we going to do? Even the worst-case scenarios of 6 degrees won't mean the end of all life on Earth. But the planet after extreme global warming would be radically different from the life we know today. How bad could it get? At that point, the best minds on Earth agree on 2 things. They just don't know, and they hope we'll never find out.